Okay, Katie, you're going to be the first. Are you ready to go?
Oh, I am. I think so.
Okay, I'll tell you when to start. Okay, Katie, you can start now.
Cool. Hello, everyone. So today I'm on Team Paleozoic, obviously, because the Paleozoic is the best. And I've decided to go with a bit of a random one because of, well, just how awesome they are, which is crinoids from the Carboniferous. So this slide here shows you some of the stuff that Team Paleozoic is going to talk about. On the left-hand side, we have our geological timescale, and the Carboniferous is probably most famous because that's where most of our coal deposits come from. But it's also very famous because you get loads and loads of crinoids during this time. So one of my favorite crinoids is called Fibroclinus, and I really like that one because obviously of the name. But what's really interesting is that we have a lot of limestone in Scotland from the Carboniferous, particularly the early Carboniferous round about the Visean time. And what's interesting is that a lot of the rocks, the limestone, are actually composed entirely of bits of crinoid. And what other fossils do you get really that make up entire rocks? It's just really, really awesome. On the right-hand side here is a picture of Invertail Quarry, which is near Crocodile. And this one has been quite famous for its crinoid preservation and the type of material that you get there. So quite often when you find cranoidal limestone, you find just basically the stems of the crinoids. So I'm going to show you here this diagram on the left, which is showing you how sort of abundant they were during the lower Carboniferous, which is what most of the limestone around where I live is. But during the Carboniferous, there was 4 distinct groups of crinoids, and the ones that I like the best are the Cladded Crinoids. And these have quite diverse branched arms, and one of the things that's diagnostic of them is that the arms tend to be free above the cup, and this diagram down here shows you the cup, and these are the arms, and they normally possess no oral plates or very few, and they have these things called anal sacs because crinoids usually have their anus next to their mouth, because why would you not do that? But what's also really cool, on the right-hand side here, I've got an image from a paper which shows you some of the different crinoids that have been found at a quarry over in Ayrshire. And the top one here, this is Fibroclinus. Now, what is interesting about crinoids is even though we find all these stems, and they're one of the most abundant fossils from this time period, we actually know very little in terms of their taxonomy. So that means what species were where, and that is because they're quite fragile. So you have your crinoid that is made up of a stem that is attached to the seafloor with its arms waving about. And when that dies, it just gets completely broken up, and you end up with this rock that's just made up of this big mess of stem. So it's quite rare for you to find these cups, which is usually what we need to look for to try and identify them. So I like that crinoids are just super mysterious. And I'm going to show some pictures in a wee minute of the really cool crinoidal limestones you get, so you just see how abundant they are. But first I wanted to talk about crinoids that have had some sort of infestation or parasite. So this image here, you can see these bulges. These bulges are known as Oculus Simplex, which is a parasite which has essentially been sort of burrowing into or boring into the crinoids, and it causes these bulges. And that's really cool. You're seeing evidence of 330 million years ago that these animals were being infested. And I'm going to move on because I'm aware that I don't have much time and this is very stressful. There's too many good things to talk about. Okay, so pictures here in the middle, I have some examples of this absolutely beautiful crinoidal limestone. One that even has a little cup in here. And it's so beautiful. So this rock is not only important or interesting because it's made up of crinoids, but a lot of this limestone was super important in Scotland's Industrial Revolution. And that is because we used it to burn to produce lime mortar and fertilizer for fields. And you can see there's also some really cool things that you can see on the stems of crinoids on this one. See these little branching bits? These are another animal called Bryozoans. And I feel like my time's nearly up, oh my God. And they also were home to loads of other animals. So there wasn't just crinoids, there would have been corals and other invertebrates, but there were also really awesome sharks. And this is a shark tooth from Petalodis, which is here, and you can see this crinoid that's in cross section. And quite often in the limestone where I am, they have this lovely, beautiful sort of smoky quartz center, which is really cool. And I wanted to show you this one because another reason that crinoids are super awesome is that sometimes you do find them almost articulated and they look like robots. So I think you should vote for Paleozoic robot crinoids.
Okay, I'm afraid we are out of time. I hope the klaxon wasn't too alarming for everyone there. Well, that was quite something. We had anal sacs, we had bums next to mouths, we had very strange little discs and severed fingers. Wow. So does anybody from Team Mesozoic or Cenozoic have anything they would like to say in response to Katie's choice of crinoids as the best fossils in Scotland?
I saw there was one comment about I had sharks and I picked this fella. But yeah, we wouldn't have had the sharks if they didn't have this cool marine environment to swim about in. So,
okie doke. Well, thank you, Katie. That was super. So, crinoids, if you think that they are Scotland's greatest fossil, then you can vote for them at the end. Meg says that they are pretty awesome. Okay, Sandy, you are up next. Now, Sandy is, well, I'm not going to list all the amazing things you are, but you're a researcher at the University of Edinburgh, aren't you? And you work on plants. And I think, you know, I'll leave it up to you if you'd like to do any more introduction. Sandy, let us know what you have picked as your greatest fossil in Scotland.
Oh,
and hang on, your timer will start.
I haven't got, let me share my screen.
Oh, well, you're going to have to hurry.
I'm trying. How's that? Can you see that right?
Yes, it started. Okay, you ready?
Yep,
Go.
Fantastic. Brilliant. So yeah, I'm representing Team Paleozoic, and today I'm going to be asking you for your vote for the Cradleaf tree. So when I think of Scotland, I'm normally thinking of mountains and fells and the amazing glens, all covered in a rich diversity of plant life, like heather and forests. However, this just really wasn't the case for much of the history of Scotland. In fact, for the vast majority of Scottish history, there were no plants on the surface. And so the reason I think you should all be voting for Team Paleozoic is this was this amazing time when plants colonized the land and completely transformed the terrestrial surface, producing these enormous forests which covered blanketed Scotland in the Carboniferous. So vote for Team Paleozoic because it's this key time involving the greening of Scotland. And because of this, there's an amazing fossil record of plants. And today, the plant fossil in particular I want you to focus on is the cradleaf tree. So what is the cradleaf tree? Well, the first thing is, how does it get its name? And it gets its name from the area of Edinburgh known as Cradleaf, which is located here on the map, you can see. And if you go to the site where this fossil was discovered today, you'll be standing right in the middle of Cradleaf Retail Park. So it's a pretty surprising place to find this enormous fossil tree. However, the reason for that is that Cradleaf Retail Park is on the site of what is one of Edinburgh's most famous quarries, Cradleaf Quarry. And quarrying works have been going on there for, for over 300 years, mining huge amounts of Carboniferous sandstone. So here's an amazing photo of what Cradleaf Quarry looked like in the 1880s. You can see these enormous quarry walls that were over 100 meters high, and then looking towards the castle in the distance. And in fact, it was lots of the sandstone quarried at Cradleaf Quarry that went on to be built into many of Edinburgh's most famous landmarks, including the castle, Edinburgh University Old College, and much of the new town itself. But it was while excavating this quarry that they came across this amazing fossil, which have become known as the Cradleaf trees. And this was the first one that was discovered. So here are images taken from a paper by Whitton in 1834. And it shows the discovery of these amazing fossil plants. So here's a amazing image of what the quarry looked like. You can see the path winding up, and you can see this tree here being when it was first discovered. And here's again the artist's illustration of this tree being discovered and slowly excavated. So this tree is enormous. It's over 10 meters long, and actually it's an amazing feat that they were able to excavate this tree only into a few separate parts and were able to get it out of the quarry safely. Now, the wood from the tree actually holds a very key place for paleontology because it was actually one of the earliest ever fossil thin sections was made of the wood of this tree. And they were made in around 1831. And actually, we can still actually examine these thin sections today, such as this example in the J.D. Hooker collection in the British Geological Survey. And it was from examining these thin sections, they were able to examine the wood. And they found that the wood was really similar to modern conifers today. And in fact, we now know that these trees were what are called seed ferns, an extinct group of plants. So really key kind of scientific finding. And after its discovery, it became a key part of kind of Edinburgh history, and in particular, the history of the Edinburgh Botanic Gardens, which is where it has basically been based for a really long time. And I hope these images just give you a real feeling for just how big this fossil tree is. Now, the journey of this tree hasn't finished yet. It's actually currently just about to be conserved and has been taken away. And we'll be back in Edinburgh again in 2027 when the Edinburgh Biomes project opened at the Botanic Gardens. So really, I think the reason I think you should all be voting for the Craig leaf tree is it reveals the ancient Carboniferous history of Edinburgh itself. It was a remarkable find, being 10 meters long, that they managed to get it out and excavate it, and tells us a lot about many of these iconic buildings in Edinburgh itself. And finally, I just want to end by saying that I've only been talking about one of the Craig leaf trees, and actually there were multiple trees found from this quarry. And one of the most famous you may have actually all walked past, and that sits outside the Natural History Museum in London. And given that these trees have been on display in the Natural History Museum in London and at the Edinburgh Botanic Gardens, I really think these trees are likely some of the most viewed fossil plants in the entire world. And so with that, I will end and say vote Team Paleozoic and vote for the Craig leaf tree. And thanks everyone for listening.
Wow, I didn't even need to do my klaxon. That was very impressive. You can tell that you've given one or two public talks in your time. Used to conference talks where you've only got like a tiny amount of time to get your point across. Well, that was fantastic. I really enjoyed that. I particularly want to go to Craigleith Retail Park and find trees now. That sounds like my kind of retail park. So teams Mesozoic and Cenozoic, does anybody have any comment to make on the fossil tree from Craigleith? No, you're all just, oh, trees, Fui is in the chat. I think everyone's just overwhelmed by the wonder of the tree, really. That was fantastic, Sandy. Thank you very much. So without further ado, straight on to the third of Team Paleozoic. Richard, are you ready and are you there?
I am indeed ready and here.
Okay, brilliant.
If you can hear me.
Can indeed.
Cool. So I'll just share my screen. Okay.
And your timer starts now.
Cool. So I'm Richard, and I'm going to try and persuade you that you should come to the Paleozoic for the trees and the crinoids, but stay for the fish, and disregard all the nonsense you'll hear later about dinosaurs and things being the best fossil. So we're going to go straight to the middle of the Paleozoic, which is the Devonian, sometimes known as the age of fishes. And the reason for this is that most vertebrates, animals with backbones in the Devonian, were of the fishy persuasion, swimming around in the seas and the rivers and the lakes. And some of these fishes you'd have recognized. Some of them would have looked like kind of early sharky things. Some of them would have looked like early sort of ray-finned fishes, like trouts and things that you get today. Others wouldn't have looked very much like you, but would have been your early ancestors, and later in the Devonian would have hauled themselves out onto the beaches to become land vertebrates or tetrapods. But lots of these fishes you wouldn't have recognized at all. And so, for example, this large kind of group of fish is called jawless fishes. Jawless fishes, as the name suggests, don't have jaws, so they all swim around looking very surprised, like you can see in these ones on the right. And they kind of reach kind of their heyday, well, maybe their heyday in the late Silurian and the early Devonian, which is where we're going for our fossil friend. And I'm going to be talking about the guy on the far right of this slide, who is called Kefaluspis. And so Kefaluspis is a member of a group called Osteostracans. And this fossil is collected from the early Devonian of near Forfar in Angus in the 19th century, and it's now in the National Museum of Scotland. So here's the star is approximately where it's from. And to help you understand Kefaluspis, because it's a bit hard to interpret, it's got this big horseshoe-shaped head shield. It's got its eyes in the top of the head shield for looking up. It's got this opening between the eyes, which kind of looks like its mouth, but is actually its nose. And then its mouth was underneath the head shield, and it would have kind of plied a life as a sort of bottom feeding detritus hoover, eating, kind of grubbing around in the bottom of the body of water. And then its body is obviously stretching out behind it with a tail. You'll be pleased to know its bum is in the correct place, unlike some fossils. So it's about the size of a trout. So why, I hear you cry, have I chosen this trout-sized muck feeder for my best fossil in Scotland? And the reason is, sticking out from behind its head shield, it has two fins, paired fins. And so these paired fins are the same as if you imagine like a goldfish swimming around or a shark cruising around. These fins that all living fishes, well, most living fishes have behind their heads, which we call pectoral fins. And in Kefaluspis, you can see they're covered in these little scales. And we know from other fossils of osteostracans like Kefaluspis, that these fins had an internal skeleton. So this is one from Canada. And these little dark things you can see in this zoomed in fin are like a little set of skeletal elements supporting the fin. And that means we know that Kefaluspis could have kind of moved its fins around to swim around the Devonian waters that it lived in. Why is this important? It's important because osteostracans and Kefaluspis are the first vertebrates in the entire fossil record to have these paired fins, which they could move around and swim with. And so in them, the origins of all modern fishy fins lie. So this is obviously important for fishes. If you're a goldfish, you'd feel pretty strongly about having your fins, I'd imagine. But it's also important for us. And the reason for this is that later in the Devonian, fishes started to use these fins to crawl out of the water and onto beaches. This is Tiktaalik from the Arctic, which was doing this with its fins. In the late Devonian, it kind of hauled itself up onto land and tried to make a go of it. Obviously, things got worse after the Devonian because everything started going on land because Devonian fish are the best. And then even later, things continued to go downhill as things moved onto land. This is as things kind of amphibian things started to get kind of stumpy legs that they could, I guess, waddle around more than walk on. And later on, the fins became even more kind of specialized and well, could be used for running around or climbing or fighting. And later, a strange group of monkey-like things started to use these fins for things like climbing trees and, I don't know, throwing poo at each other and sending insults on Twitter and that kind of thing. And so we find these fins adapted into arms and legs, which we see, of course, in us. And this is why Kefaluspis is cool, because it lays the groundwork for these arms and legs, these things that you use every day, but we see it in this exceptional fossil fish from Scotland. And this is why the Paleozoic generally is a very cool time. You have the origins of things like industry, as we saw with the crinoids, of cool plants like we saw with the Carboniferous Cradle Tree, and in all these early vertebrates, we see the origins of bits of your anatomy that you take for granted, like your fins, like we've seen, your arms, like we've seen, your mouth and jaws, how your bone works, how your brain is structured. All of these things we can find in these Paleozoic fishes. And so I ask you, when it comes to voting, to take your fin and slap it down on the keyboard in place of Kefaluspis to vote for Team Paleozoic Kefaluspis. That's it. Thank you.
Oh, just in under the wire there. I was getting my claps ready. It's obviously so alarming that it's frightened everybody else off from.
Yeah, I was watching my timer like a hawk.
Yeah, maybe 5 minutes was too long. Maybe the rest of the team should only get 3. What do you think, Team Paleozoic? Maybe. Okay, that was fantastic. I'm really pleased to know that by this point in time, things put their bums in the right places. And you know, I very much appreciated your journey into the later time periods, although arguably you were maybe persuading people that the Mesozoic and Cenozoic might.
I was trying to show that it was all going downhill and that it peaked at the
Devonian. Well, it might have backfired. I don't know. We'll have to see. Do either Team Mesozoic or Team Cenozoic have anything they would like to come back with to Richard's plea for his fossil fishes?
I think Richard did help us a little bit in saying that it all went downhill once things went onto land, because obviously things go uphill once they go onto land.
Yeah, I have no riposte to that. That's very true.
Okay, let me reset my timer and double check. Let's see. So next up, we have, thank you, Richard, by the way, I should have said thank you, Richard. Next up, we are moving to Team Mesozoic. So we're going to start off with Neil Clark, who, among many things, is curator at the Hunterian in Glasgow. Neil, are you ready to share your screen?
I'm ready, but I'm not sharing my screen.
Okay, so you're just going to talk.
You'll just have me.
Holy moly. Okay, is everyone ready? The timer starts now.
Right, well, the Mesozoic is my favorite age, obviously, because it is the age of dinosaurs. And it's no surprise that my favorite fossil is actually a dinosaur as well. This isn't a fossil, but this is the kind of fossil that's my favorite dinosaur. And Scotland, of course, is one of the most exciting places in the world for dinosaur finds, because unlike North America, where we expect most of the dinosaurs to have been found, they only have remains really in the early Jurassic, the late Jurassic, and the Cretaceous. But in Scotland, we're very special because we have fossil dinosaurs from the Middle Jurassic, and worldwide, it's very rare to find Middle Jurassic dinosaurs. So we have all things including sauropods. Here's a sauropod. We have theropods. Here's a theropod. And we also have representation from the ornithopods. Now, the Middle Jurassic, as I say, is poorly represented worldwide, and it's a key geological time when familiar dinosaurs of the late Jurassic and the Cretaceous start to diversify and evolve. And the vast majority of finds in Scotland, sadly, are mostly the footprints. We do have quite a number of bones. This isn't one from Scotland, but this is a representation of dinosaur bones. And we do have dinosaur bones from Scotland, but that's not what I'm going to be talking about today. My favorite fossil is not a dinosaur bone. Now, to put it in context, the first evidence of dinosaurs in Scotland was a single footprint that was found in Skye in 1982. And since then, there have been hundreds of dinosaur footprints that have been found, ranging from large, giant sauropod footprints up to 70 centimeters in diameter, down to very small theropod dinosaur footprints of about 15 centimeters from Score Bay. And of course, dinosaur trackways and footprints help us to better understand how these animals moved around, how they interacted with each other, and how they interacted with the environment. So this fossil here is my favorite dinosaur footprint that I found in somewhere around 2003 in Score Bay. And it was only after I returned to the Hunterian to measure the footprint that I actually found that it was a little bit more interesting than just a footprint, which you can see here. When you look at it very closely, you can see that there's actually a little footprint inside the bigger footprint. And we have a look at this a bit more closely. And if we put a dinosaur that's about the right size into the footprint, you can see that this is about the size of the dinosaur that made that footprint. So it's a very small dinosaur, probably a baby dinosaur. And of course, what happens when you find something really small is that you go to the oracle of all things big and small, the Book of Guinness World Records. And when I put it to them that this footprint was 17.8 millimeters in length, they came back and said, yes, that's the smallest dinosaur footprint in the world, and presented, obviously, the Guinness certificate to prove that. Now, the exciting part for me as a paleontologist is not that it's the smallest or the biggest or anything like that. It's what does this represent? Does it represent parental care within the animals? And the answer to that is yes, it probably does. It probably was very close to where the animal hatched. So make sure you vote for the truly record-breaking, awe-inspiring, globally significant, tiny Mesozoic fossil dinosaur footprint. Thank you very much.
Whoa, wow.
And how does that
Okay, everyone.
That was 4 minutes.
Neil, really, you went to town there. Not only did you have props and an actual fossil or a cast, I don't know, but a record-breaking. It's going to be hard to beat. It's going to be hard to beat. Okay, Team Paleozoic and Cenozoic, do you have any comments you'd like to make on the smallest dinosaur footprint in the world found in Scotland? No? Yeah, people are saying having to like basically fight against cute baby dinosaurs is going to be difficult.
I think Richard was going to say something.
Yeah, it strikes me that really this is just a fin print, right? We're back on fins, back on paired fins being a fundamental part of.
Yeah,
so your argument is like, why go for it later? Why not just go for it even earlier when it was a fish?
Precisely, and even smaller, I imagine.
I see. That's an argument. Okay, right, we're moving swiftly on. Kim, are you there and are you ready?
Hello, yes.
Okay. So Kim, you are a PhD student in Berlin now, aren't you? Oh, you've got
Yes.
it here. Cool. Okay, great. So take it away. Your timer starts now. What is your fossil?
Brilliant. Hi everyone. As I said, my name is Kim. I'm a PhD student at the Museum für Naturkunde in Berlin, where I am studying how the skull roof evolves in early tetrapods. So even though I'm now technically working in the Paleozoic, my heart is still very much within the Mesozoic. And if we're going to talk about what the best Scottish fossil is, it's got to be a marine reptile. I mean, we're the homeland of the Loch Ness monster. So the best fossil's got to either be Nessie or one of her mates. And we actually have a lot of different marine reptiles in Scotland. We have the Nessie-like Plesiosaurs, which had very long necks and short tails. We also have the Pliosaurs, which were the short-necked morphs. These guys were ambush predators and would have eaten anything they could get their flippers on. Then we have Ichthyosaurs. These guys are kind of like a cross between a dolphin and a shark. They would swim by moving their tails from side to side like sharks, and they had large eyes that were adapted to low light conditions. And then, believe it or not, we also had crocodiles in Scotland, such as this guy, a Teleosaurid. They were semi-aquatic and covered in body armor, and they're quite like modern-day gharials with their very long snouts. Now, we find marine reptiles in several different places in Scotland. We've found some on the northeast coast in Helmsdale. There we've found late Jurassic age marine reptiles such as plesiosaurs, the first Scottish pliosaurs and ichthyosaurs. Then on the west coast in the Inner Hebrides, like on Skye, Rassay and Egg, for instance, the Hugh Miller bed bones, there we've found several plesiosaur specimens. We've also found ichthyosaurs and crocodiles. Now, what is the best Scottish fossil, I hear you ask? Drum roll, please. It is NMSG 2020 11.1 Telescoridia Indeterminate. That's right, the best Scottish fossil hasn't even been diagnosed to species level. Now, the reason why this specimen is my favorite is partly because it was actually found by an amateur fossil hunter. And I think this is a really great example of how anybody can get involved in paleontology. You don't need to have fancy degrees to go out and find a fossil. And this was found by a man called Gert Keitens. He was exploring one of the beaches on Skye when he came across this cobble. He then kindly donated it to the National Museum of Scotland, which meant that I was able to study it for my master's research. And as you can see, there are some bones visible on the surface of this rock, but there's a lot more going on inside. So we decided to CT scan it. Just like if you'd broken your arm, you'd go to hospital and get an x-ray to see what was happening. We x-rayed the specimen to see what was happening inside the rock. And using that data, I then created these gorgeous models to find out what was happening. And using these models, we were able to look at the individual bones and decide what kind of animal this was. So looking at the vertebrae, for instance, we can see it's got a very crocodile-like shape. If you look at it on inside view, it's kind of quite a hourglass spool-like shape that's typical of crocodiles. And then these things called osteoderms. This is the dermal armor that even modern day crocodiles have. And by looking at the shape of the osteoderms and the pattern and morphology of the pits on the osteoderms and comparing that to other crocodiles from the same time as this specimen, which was the early to middle Jurassic, we were able to determine that this belonged to a Teleosaurid. And this is really interesting and exciting because this is the first Teleosaurid crocodilomorph to have ever been found in Scotland. But not only that, it's also the most northern Teleosaurid in the world. Previously, the most northern Teleosaurid had been found in Yorkshire. And with this new specimen, we've got even more information about the distribution, the paleobiogeography of these animals. And that's why this rather unassuming looking rock is the best Scottish fossil. It's a frickin' crocodile in Scotland. It's the first Scottish Teleosaurid, the most northern one in the world. And it was found by an amateur fossil hunter. It's a great example of how anybody can get involved in paleontology. And that's why you should vote for Team Mesozoic.
Wow, that was, there's been a lot of kudos in the chat for your slides there. In fact, you've had like the most chat of anyone so far. Natalia is suggesting that not voting for Nessie would be considered unpatriotic.
Right.
So, but Richard counters that, of course, that all these animals have realized their mistake of leaving the water in the first place, and that's why they've gone back. Ross assures us from his position on Loch Ness side that Nessie is in fact Team Cenozoic. I think Neil said the same thing, that it's not a Mesozoic animal. However, that wasn't your actual fossil you picked, so that's fine. Yeah, what else have we got? Gosh, there's lots of stuff in here. You're going to have a look. Indeterminate, says Ross. It is Croctober, says Scott Reed, so it would be appropriate for that. Yeah, lots and lots of ants there. Does anybody want to add anything from Team Paleozoic or Cenozoic?
I just want to say that Croctober should win, hands down. I don't mean those slides, but I mean the portmanteau. That was brilliant, Scott. Brilliant.
Okay, cool. Thank you very much, Kim. That was super. So we're going to hand over to the third member of Team Mesozoic. That's Natalia. Are you ready?
Yeah, one moment. Let me set things up. Oh, can you see this?
Yes. It's a bit slow on my end, but that might just be my connection.
Okay. Can you hear me right? Can you see me? Yep. Oh, I think also crashed on us slightly, at least for me.
Can everyone else see it?
Yeah.
Hi. Okay, great. Neil's put his thumbs up. Okay, right. I'm starting the timer now. Here we go.
Okay, hi guys. I'm going to show you that why you should support Team Mesozoic by showing you one of the worst and shittiest of fossils that has been found in Scotland. Everybody hates this fossil because look at it. You don't even see a bone. Most of it is not a bone. It's an impression left by a bone in a sandstone. It's very hard to study, and everybody's very angry at this small thing. And it caused a bit of controversy. Throughout times, it has been compared to a different kind of creatures. It's called an arbor climbing and leaping pseudoscian, a float sprawling quadrupedal hopper, small bipedal running leaping dinosaur. It was an aquatic animal with a long neck and a gliding membrane spread with the hindlimbs. But what caused so much trouble from this kind of fossil, and why is it important? Well, those small leggy legs with long metatarsals suggest it might be the big ancestor, or at least sharing the same ancestry with dinosaurs and pterosaurs. And it's a big deal because dinosaurs and pterosaurs evolved and thrived throughout Mesozoic, like Jurassic and Cretaceous. We have no idea from what the origins. This small, tiny thing, the scleromoculus, can provide some resolution. So the scleromoculus, the fossil uncovering, comes from Elgin, from Lossiemouth sandstone. And back then, Scotland was not as harsh and Icelandic as it is now. In Triassic, it was actually in part of a continent. It was very dry and arid and nothing like we have currently. In fact, we had migrating dunes that sort of moved up in the landscape and covered animals like Oscleromoculus. So absolutely nothing as we have currently. And Triassic is in an interesting period. It's before all the fun stuff happens in the Mesozoic. So before we have your famous Stegosaurus and Triceratops and T-Rex and all the Hollywood superstars, we start with the underdogs in the Triassic. And Triassic is super, super cool because it came after Permian, and Permian is a bad period. It was a bad period if you were any animal, because Permian was a period of mass extinction. So most animals died, paving the way for brand new newcomers in Triassic. And Triassic was excellent because back then we had a lot of experimental animals, just filling niches left by the Permian. And one of those experimental creatures was old tiny Scleromoculus. And lived in a world of animals that weren't fully dinosaurs yet. We have things like Saltopus, which might be a dinosaur, we are not sure, but a lot of experimental synapses, anapses, crocodilomorphs, and other things like that. But it's problematic. How do we study something that doesn't really have that much of a bone preserved in the first place? And we have a lot of them. There's a lot of Scleromoculus fossils with full skulls preserved. Some of them are sharing the same slab, but how do we actually know and study them? Well, it's very, very tricky. They have been studied creating casts of the bones. And they're created using wax squeezes, clay and glue casts, some low illumination photography, silicone impressions, and some of them actually destroyed the fossil itself during the studying. As we're talking right now, there are new studies made using new digital techniques like CT scans, which are less destructive, helping us to understand this prehistoric creature. And it's important to understand it because now we have no idea how it locomoted, how it stood, and how it looked like. There's a lot of competing interpretations just because of how it is preserved. Whether the long metatarsals over here used for plantigrade stomping like we do with humans, or they digitard and stepping on tippy toes. It's really interesting and important because it will help us pave the way of understanding how first vertebrates took to the skies, were they arboreal or were they jumpers, and if they're sharing the ancestry with pterosaurs, how did they eventually pave the way for first flying vertebrate animals? Even in 2020, we had competing ideas regarding Scleromoculus. So even though they were discovered hundreds of years ago, we're still arguing whether they were more froggy or kind of jumpy. And recently, there has been some new revelations with the discovery of other small reptiles called Lagareptids from Triassic of Southern Africa and America. And they share similar morphology of hind limbs, suggesting they as Scleromoculus are related. And we are pretty confident that Lagareptids were close ancestors of pterosaurs. And I study pterosaurs for a living. They are absolutely amazing. And we have pterosaurs in Scotland. I'm currently discovering an enormous big pterosaur that's nothing like we have seen previously. And there are other remains of pterosaurs like this wing bone from Aphie. So if Scleromoculus proves to be a pterosaur ancestor, we'll have entire swath of discoveries of pterosaurs coming from Scotland, which is exciting because pterosaurs are very hard to preserve and interesting to study. I also love Scleromoculus because it shows how interpretative the fossil record is, and even old fossils can show us brand new information. It also shows tiny steps of something enormous, new enormous things to come in. Yeah, in Mesozoic. Thank you. Got it.
Wow, that was amazing. Okay, cool. We've had lots and lots of, I should have actually said, I'm really bad at hosting. I should have said that Natalia is a PhD student at the University of Edinburgh, who is slightly biased because she studies pterosaurs, but is also an exceptional artist, as many people in the chat have been pointing out. Really beautiful artwork there. Thank you so much. So there's been a few comments in the chat about where all the big dinosaurs are, because we're only seeing small ones. Neil and Natalia, come on, where's the big ones at? People like big stuff, don't they? It's definitely no crinoid. Dave Longstaff wants to point out that you can read all about Scleromoculus in the Elgin Museum's new book, The Elgin Reptiles, which I think is definitely worth mentioning. A lot of people are saying that it's going to be very, very difficult to choose because the showing is so good so far. Right, does anybody from the other two teams, Paleozoic or Cenozoic, have anything they'd like to come back at Natalia before we move on? Any comments? No. All stunned by the incredible artwork. Okay, thank you, Natalia. That was superb. We are going to move on now to the last but not least team in our lineup. This is Team Cenozoic. And we're going to start with James. Are you there?
Yeah, I'm here.
Great. So, James, I'm not sure how to introduce you. You are all things Mull. You are the Mull expert. And you're going to be bringing us to Mull in your talk, I do believe. That's
right. Yep. I spend most of my time doing Mull geology on social media, trying to promote the place. You know, there's all these people that come here for sea eagles and otters and stuff like that. But there's a whole lot of geology out there to be discovered and looked at.
And you're like, stop looking up and look down.
Ah, exactly. That's it. Yeah.
Right. I'm about to start the timer. So are you ready to take over the screen?
Ready to share my screen? Yeah. Let's just, where is it? Where's it gone? Okay, ready to roll.
And away you go.
Right, I'll start my own timer. Okay, I'm going to talk about Mcculloch's fossil tree in Mull. Right. 7 questions. What is Mcculloch's fossil tree? Where is it? How old is it? What does it look like? How do I get to it? How well preserved is it? And why is it special? Why you should vote for it? First thing is Mcculloch's fossil tree is an early Paleocene age tree. It's been engulfed by lava and now remains as a mold with some remaining wood at the base. That's Mcculloch who found it, and he described it, a Scottish geologist. He found it in Mull, and he described it in a paper that was published in 1819, which we see in the reference for there. So Where is it? Well, there's Mull. And that arrow points to where the tree actually is. It's a place called Ruanahua in amongst the Staffa lava formation. If you want to get to it, you have to start about here. A place called Tiroran. That's where the starting point is at the car park. It's a long walk to it. And it's wild, broken country. They don't call it the wilderness for nothing. Spectacular. That's what it looks like. And it's right at the very left-hand side of that picture. So, how old is it? It's early to mid-Paleocene, according to Bell and Williamson's paper, 2017, right near the start of the Cenozoic. It's in what's called the Staffa lava formation. It's the lowest member of the Mull lavas. There are other plant remains elsewhere in the Staffa lava formation that you can find. And on the stratigraphic column, where does this put it? Well, there's the main column and there's the Paleogene there. Go into the Cenozoic and it's in about there. What does it look like? Well, there's a group of people gathered at the foot of the fossil tree. And there's a film crew looking at it I was with a couple of years ago. Dimensions about 12 meters long, 1.5 meters wide. And there's a close-up picture of one of the film crew. Also nearby, there's some carbonized wood, lots of wood fragments nearby. And there's a cave nearby as well, near these lovely basalt columns that's also got some fossil tree in it as well. So the Staffa lava formation is a lava flow. It's got lots of interflow sedimentary units. So there's been long periods of quiescence with colonization, erosion of the lava, things growing on it. The fossil tree was one of these plants. So how do we get to it? Well, the first thing you do is you park your car at Tiroran, near white-tailed gin is produced. And it's a long hike. It's 19 kilometers there and back. State track, path, clifftop, cobbled shore. The approach is spectacular. Here are some pictures. That's what it looks like. As you approach it, it's wild country, this. It's a hard trek to get to this place. And you've got this thing at a place called Carrickavinister, which looks like the cast of a tree on the shore. Got this radial columns moving out from it. It's an amazing looking thing. There's a ladder you have to go down to get to it. And there's a couple of waterfalls at these two streams. The fossil tree is just beyond those. Long walk, and there we are. And there's a picture taken from the BGS Earthwise website with the late Henry Emilius for scale. How well preserved is it? Well, most of it is the mold of the tree. There's some actual wood at the base. You actually put your finger on burnt wood. It's possibly a swamp cypress, but its identification means equivocal, according to Bell and Williamson. It's preserved with cement over the top to prevent people from stealing it. It's an SSSI, a GCR site, and it's remote, and it's probably just as well, because I think it'd be gone if it wasn't. Why is it so special? And this is why you have to vote for it. It's a spectacular looking thing. It's very unusual. It's very rare. It's a fossil that's in volcanic rocks. This isn't something that's in sedimentary. This is actually in lava. It's had a heroic death. None of this lying down in sediments and getting covered. This is, immolated. This is serious stuff. It's spectacular, as I said before. I keep saying spectacular because it is. And it's an amazing location. You've got this fantastic scenery you've got to go through to actually get to it. I mean, that in itself is fantastic. And there's amazing geology around about it. If you like, what do you call them? Basalt columns. If you love basalt columns like I do, you'll love this location. It's fantastic. The most famous fossil tree in the Hebridean Igneous Province, is also arguably the largest, most spectacular example so far discovered worldwide, and as such is of unrivaled international significance. Bell and Williamson, 2017 paper. So, Mcculloch's tree, I want you to vote for it. Thank you. Elsa, you're muted. No, I can't hear you.
Oh no, I wasn't muted. Okay,
You're
right.
muted.
Sorry. Okay, can you hear me now?
Yep.
Super. Thank you very much for that. That was superb. We've had an awful lot of chat. So Kate and Ross are saying, what's cooler than a volcano? What's hotter than a volcano? Richard says, well, Devonian fish, obviously. Natalia was arguing that the reason that Team Mesozoic didn't show all the big dinosaurs was because it would just be unfair to the other teams, which I think is maybe a fair point, who knows. There's been some criticism that you're trying to sway everyone by showing them amazing photographs of Scottish scenery, and that's just not fair.
That's probably true as well.
lots of love of your mention of gin, and I'm one of those people, definitely. You said hero trees. Somebody else said it's a foolish death. What else? We've had an awful lot. Okay, I think we should move on to the next one, but that was superb. Unless anybody from Team Paleozoic or Mesozoic wants to verbally add anything before we move on. No? Okay, in that case, thank you, James. I'm now going to invite Ross to unmute himself. Ross, by the way, for anyone who doesn't know, is the author of a really amazing book called The Missing Links, which if you have not already read it, I highly recommend you read it. Ross, are you ready to go?
Yeah, I'm just about to share the screen.
Okay, I've got my timer ready.
All right, here we go.
And it starts now.
Okay, so thanks for the opportunity to show you what is essentially, obviously, the best Scottish fossil, the Loch Mammoth. So we've had all sorts of things. We've had things that are common, fish, tons of them, trees, tons of them, apart from the Cenozoic one, which is great. We want to go for things that are rare, like one-of-a-kind fossils that you can't have lots of and are unique and spectacular. And so we've got to go to the Cenozoic, and we've got to go to Loch Ryan, and we've got to go big. We've got to go mammoth. So we're talking about the Cenozoic. We're mainly talking about the Pleistocene, the Ice Age for this fossil. And so what was Scotland like during the Cenozoic Late Pleistocene? Well, it was like this. It was basically very, very icy. We're talking miles of ice above where all of Scotland is now. It was very glaciated landscape. There was not much there. And of course, this is a big problem because that stuff has basically scoured the land of fossils. We don't have very many late Pleistocene Scottish fossils because the ice has basically ground them all to dust, which is a big problem. But it also helps to make what we do have even more special. And so we want to get a kind of map overview of what that was like. During the kind of greatest extent of the glaciation, you have most of Britain covered, and particularly most of Scotland, where the glaciers kind of start and nucleate, completely covered with ice sheet. And this is a lot of ice grinding away and getting rid of all the lovely fossils that would have been there. So we've got practically hee-haw in terms of Scottish megafaunal fossils. We have a few bits and pieces of giant Irish elk, this guy down here on the left with my daughter there acting as a scale, the giant Irish elk. There's a few bits from the River Cree and from Islay. We've got a few bits of the lovely woolly rhino. These are actually fossils from Bishopbriggs in Glasgow. And these have been protected under various kind of geological formations that preserved them when the glaciers were kind of ripping away the top. So Scottish mammoths, we do have a couple of things from mammoths. We've got some tusks and teeth. Here's some good examples. So there's one here from Greenhill Quarry, which has been dated to about 27,000 years old. It was found in 1817, which is great. We also got some from the Clifton Hall estate, which were found when they were digging the Union Canal. Unfortunately, the guys that found it, the canal diggers, the workers there, sold it for £2 in Edinburgh for carving, and then they had to scramble and get it back because it was so important. And it's been cut up into bits, and some bits are still missing. So if you find any of that mammoth tusk, please get in touch with the museum in Edinburgh. We've also found some other bits of teeth and tusks. One really interesting kind of side note, which I've just got a few seconds to tell you about, is some tusks which were dredged 30 miles off Shetland. So from the bottom of the sea, parts that would have been dry land. And they looked like mammoth, but unfortunately they were radiocarbon dated to only being 300 years old. And it turns out they're actually modern elephant tusks that were probably part of a Dutch East Indies sailing fleet that sank off Shetland in the 1690s. Anyway, mammoths, why are they so cool? There's a couple of reasons why. We've got lots of mummies of them. We know what they look like. We have cave art of them. People saw them. People like us, sort of modern humans, drew them, interacted with them, hunted them. We can look them in the face. We've got huge kind of mummies, complete heads, whole bodies of baby mammoths as well. And we've got lots of art. So these have been drawn by people who saw the living animal. They've been carved out of mammoth ivory as well, like lovely little ornaments of mammoth ivory. And we've also got evidence that we hunted them. So these are things that people ate, people interacted with, people worshipped, maybe had a special affinity for. And they're really an integral part of the human environment at the time. and we know that they were in Scotland. But what we haven't had until just 3 years ago were any bones of mammoths. And that's where this guy comes in. So Loch Ryan is just down here near Stranraer, pointing out on the map. And one day a guy called Nick Comby was wandering along the shores of Loch Ryan, and he found this. Isn't that amazing? Like just on the beach, you're walking along and you find that massive, enormous chunk of mammoth bone. And this is the first and only so far chunk of mammoth bone that has been found in Scotland. So it's unique, it's special, it's big, and it shows, you know, that Scotland would have had all these incredible megafauna. It would have had mammoths along with the woolly rhinos and the giant deer and all the rest of it. And so it's really a one-of-a-kind thing. Here's Nick here with the bone found himself. You can see it's huge. It's currently, I think, in the National Museum in Edinburgh being studied. But you know, it's a one-of-a-kind item, and it just shows you that, you know, anyone that goes beachcombing, any amateur that can walk around, can find something as special as this. And that's why Scotland is so brilliant. And maybe, you know, mammoths haven't really gone anywhere. Maybe they're still there waiting for us.
Sorry, my mouse got stuck, but I was literally just about to do the klaxon, so you narrowly avoided being klaxoned out. Okay, thank you very much for that. We have got quite a few comments in the chat. Maybe Neil's suggesting that actually this bone just washed in from Doggerland, so it's not really from Scotland.
Well, it's on the wrong coast,
Maybe.
so
we have, what else? I might have accidentally dissed it by saying it looks like a walking. Hang on a minute, I got a connection problem there for a second. I didn't hear what you said, Ross. Are you still there?
sorry. I was just saying that so this is on the west coast. So it's probably come from the sea around the sort of Stranraer area, but Doggerland's the east coast, and this is the west coast.
Oh, well, then I think that might be what's the word? Penalty point to Neil for getting his geography so wrong. Okay, we have just one more presentation, but I think it is a shocker, this one. Kate, are you ready? Now, I should say before this presentation that there are going to be some pictures of human remains, and we're going to be talking about a gruesome murder. So if there's anybody of the faint of heart, or if there are young people in the audience, just to bear in mind, we won't be showing anything fleshy, but there are some skeletons, so just to warn you. So Kate, hang on a second, I need to get my timer. Everybody's been so good with the time. Okay, 5 minutes was definitely too much. Next year, you're only going to get 2 minutes. Okay, Kate, take it away, your timer's on.
Sorry, I had to run out then. My little girl needed me. So my fossil is Rosemarkie Man, a Pictish, that is 5th to 7th century AD, deviant burial. That's right, Holocene. Fossils all have to start somewhere. Fossilization is a process. It's not just the product. And as soon as something dies and gets in the ground, those minerals start getting replaced with minerals from the burial environment, and the process begins. And yes, as our host has pointed out, bit of a content warning here, because the following slides do show images of human skeletal remains and descriptions of physical trauma. So this skeleton was discovered in these caves as part of the Rosemarkie's Caves project, which is up on the Black Isle, north of Inverness, as part of excavations that were undertaken in 2016. Now, during these excavations, along with animal bone and archaeological artifacts, the skeleton was discovered in an alcove towards the very back of the cave. You can see here where I've circled it. Now, specialists at Dundee, who specialize in something called osteoarchaeology, that's where you look at the bones of dead people and work out all kinds of things about their lives, determined that he was a male, that he was in his late 30s, and radiocarbon dating determined that he had died sometime between 430 and 630 AD. Now, analysis of his bones determined that he was robust and in good health at the time he died. And indeed, his skeleton showed no signs of injuries, endured during life. So he was unlikely to have been, say, a farmer or a soldier, and perhaps even led quite a pampered existence. The injuries he sustained around the time of death, however, were substantial and sustained. This is the skeleton here. So indeed, Rosemarkie Man shows evidence of 5 separate faciocranial traumas, many of which were made with some kind of cudgel or fighting stick. So these include an initial penetrating trauma to the right side of the mouth. You can see there his teeth were broken with this, and this caused him to swallow his teeth. And we know he was still alive during this part of the process because they found teeth under his sternum during the excavation. There was a blow to the left side of the jaw, which broke his mandible. Contact fractures as he fell, hitting the rocks, and whilst on the ground, an object driven through his temple region from left to right. And finally, almost certainly after he'd already died, a final blow, a huge impact with a different implement causing massive fracturing and breaking to the top of the skull. Now, it's that last injury that's really interesting. And in that, there may be a suggestion that the skull was fractured to let the spirit out after death. And we see this in some earlier Iron Age examples as well. There's also the level of trauma inflicted, so far more than would have been needed to kill him. And this also raises comparisons with Iron Age bog bodies, who tended to be high status individuals who may have been willing or at least compliant to suffer what is called often with bog bodies the triple death. So in the case of bog bodies, these were typically deposited in watery pools where they had been sometimes being held down using wooden stakes. And those deaths are sometimes attributed to being sacrifices made to appease deities during times of poor harvest. So the evidence is pointing towards this not being a sort of gruesome murder, but possibly some kind of ritualistic sacrifice. And it's pretty much the only example like this, or I think the only example we have in this period in Scotland. So as well as the manner of death, the mode of death is also remarkable and very telling. His burial in the back of the cave was covered with butchered animal bones, so things like cattle, and also some complete bones of horses. So these are the remains of feasting that may have accompanied his death, and all indicate a special significance of him and his mode of death. And finally, a large boulder was placed on top of the body. And like I said, staking is typical of deviant burials, and this boulder might have been to serve to ensure that he did not trouble the dead. Did not trouble the community in returning after his death. And there's also the location itself, a sea cave. Many people regard these environments as liminal, connecting different worlds, and the same can be true of water. We can also tell things, that's the boulder. We can also tell other things about his life, and this is work I've done myself. We've looked at his strontium and oxygen isotopes. We can tell he was a local lad, born and raised in the region. Other analyses of the protein in his bones have said he has a very high quality diet, similar to very high status Pictish people we've seen in other parts of Scotland. So this again supports this idea that this man was one of the privileged, a man of high status, but one perhaps that was willing or at least prepared to make the ultimate sacrifice for the good of his community. So this is why Rosemarkie Man is so extraordinary, a unique fossil in Scotland, and something that can uniquely tell us about the power of archaeology and learning about the past, about their societies, and about individual life histories and stories of individuals who lived more than 1,500 years ago.
Okay.
Sorry about the beginning there. My child literally just chose to go to the bathroom. She's still at the age, she's very cute. I won't bring her in, but yeah, she's still at the age where they need a lot of help, and she's just next door to me watching TV and decided she needed the potty right there.
Okay, cool. That was really amazing. I mean, it is an amazing find, although some people are saying, you know, is it really a fossil? And what else have we had? We've had quite a lot of stuff here. I do think it's very Halloween appropriate to have a skeleton, and I quite like the idea that it had to be weighed down with a stone to stop it from him from haunting everyone. Presumably now they've removed the stone, he's haunting Rosemarkie. I don't know. A lot of people are saying that it's definitely a cold case, and that the perpetrator is long gone. But you pointed out it's a ritual sacrifice. So, Nick Fraser said, but this is Holocene, it's mere gardening. Ouch. Okay, what else have we got? Natalia said he sounds like some fancy pompous rich guy who's eating fancy fish. Who cares, basically? Yep. Anything else? Richard, placoderm bite marks on Paleozoic fishes. What's that got to do with anything? I think he just wants to talk about
Neil's comment is really the
Oh, okay, I missed something, sorry. That's my fault. Neil, what have you said? Yeah, you're talking about how there's Mesozoic fossils that have also been through the wars. I think it's interesting as well, you're saying that Rose Markey Man is a local boy, but then, you know, I guess so are all of the fossils, which is why they're in the first ever world's first Scottish Fossil Showdown. Okay, does anybody from either of the other teams have anything else they would like to add before we move on to the voting? No? Does anybody want to ask any questions before we open the vote? No, everyone's just desperate to vote. Okay, so what I'm going to do is I'm going to be placing the, I'm just putting my timer on, I'm going to be placing the link in the chat in just a second, and then I'm going to start a counter, and there's going to be 2 minutes during which, if you want to ask questions, if you can't make up your mind, if you can't decide between two of the fossils, you can ask the people about them and try and make up your mind in those final few seconds. Right, so you're going to have 2 minutes to vote, and I'm just going to post the link now. Okay, the timer is on. If anybody has any trouble getting into it, please let me know. I'm sure we can fix it for you. But hopefully everybody can be voting now. What am I going to vote for? Ooh, difficult. Do we have any final comments from our presenters to persuade people why that they should choose yours rather than anybody else's? No?
I think everyone should remember Kefaluspis, without whom they couldn't press the button to vote.
This is a really good point. Yep. I think there aren't that many. Oh, sorry, go on, Kate.
Rose Markey Man's had a horrible day. I mean, I just went through all the awful things that happened to him. Why don't you make him smile by voting for him?
Good point. Good point. I mean, I think those are two of the only ones that we're like reasonably closely related to. I mean, some of the other ones they're distant relatives. I mean, who cares, eh? Neil?
Yes, I would like to see a Kefaluspis try and push one of the buttons. At least the dinosaur had fingers and they would have been able to touch the buttons and perhaps vote.
Sadly, we'll never be able to prove whether or not Kefaluspis could press a button. So I think it's moot.
Okay. I'm going to vote as well. Who am I going to vote for? Okay, we've got 20 seconds left. Okay, I voted. And then I've just got to figure out how I actually see the results, which is going to be interesting.
Some people are asking how we vote. It might need a.
So when you
showing.
click the link that's in chat, so I put a link in chat. When you click it, does it open? It should open like a series of choices, and you click on one of them, and then click submit at the bottom, and it should do it. I'll not close it just yet and give you a second to have a go. So anybody who isn't able to. I'll just hang on a few more seconds just to make sure. Okay. Now I've hidden the results from myself, which is not very helpful. Oh, come on. Give me just 2 seconds. For some reason, this is being difficult with me. I did test it, by the way. So I'm not doing this completely blind, but for some reason it's not working. It's not showing me right now. Come on. Oh, that's why it's because I've hidden them. Okay, hold on. Come on. Who has won? And the winner of the first ever Scottish Fossil Showdown, can you all hear me? Is Kim. Well done. You got 22% of the vote, with the sky sorry, Nessie's for the win. Now, in terms of who won overall, can anyone do some quick maths? So it's 10, 20, 32, 20, 30. I think the Mesozoic won as well. So I'm afraid Team Mesozoic, you are the winners. I'm afraid Cenozoic and Paleozoic, you did not manage to persuade people that having your bum next to your head or being brutally murdered in the Pictish times was the best way to go. Okay. Thank you all so much for voting, and thank you to all of our presenters. I will take a screen share of that as well, and I'll post it on Twitter, so if anybody wants to have another look at those results and scrutinize them. Kim, are you there as our winner?
Yes.
Would you like to make a comment?
Well, thank you everyone for seeing sense and voting for what is clearly the best Scottish fossil.
Well, I mean, this is actually science, and this is scientifically proven now that your blob of rock from Skye is actually Scotland's greatest fossil. Yeah,
you know, looks aren't everything.
Oh, quite. And I think also it's probably a good idea to go to Ross, you've got the least votes, and say, Ross, commiserations. How are you feeling at the moment? Nobody likes your mammoth.
Yeah, I feel pretty devastated, to be honest. Well,
better luck next time.
Yeah.
Well, thank you everyone for joining us, and thank you so much to all of our teams. Claps to you all for your presentations. Hopefully we can repeat this event next year, but I think we'll only give everyone 3 minutes next time because you had far too long to persuade us. Okay, great. Thank you everyone for coming, and that was the end of our Scottish Fossil Showdown. Cheerio for now.